Good afternoon again, and welcome to today's webinar, European AI Applications, Large Language Models for Business. I'm Eva Gergely, and I'll be your host for today's event. I'm very glad to see that there are some familiar names here. So welcome back again, and welcome to all other participants. Today is actually the second installment of our webinar series. In our previous session, we delved into the topic of customized AI, train your own large language models. And the recording of the previous webinar can be found on our YouTube channel. And likewise, today's session will be recorded and be made available on YouTube. And you will find most slides on our website. Before we begin, allow me to introduce EuroCC Austria, who are organizing the webinar. Over the past few years, the European Union has made substantial investments in the development of robust supercomputing infrastructure, with the goal of strengthening accessibility for research, scientific exploration, but also for commercial applications. And since 2020, the establishment of high-performance computing centers, such as EuroCC Austria, has been a key initiative. And we are more than 30 European countries, including Austria, participating as high-performance computing centers. And we are dedicated to supporting researchers and businesses in utilizing high-performance computing, big data, and artificial intelligence. The competence centers offer technical expertise, consultation services, project support, comprehensive training, and other services. And so if you are participating from Europe, I would highly encourage you to explore the list of national high-performance computing centers in your countries or in other European countries for further engagement. And you can find the link on the slides. Today's webinar focuses on large language models and on how startups and established companies can use generative AI for their products and services. Since Europe has a diverse linguistic landscape, it is often challenging for businesses to adopt large language models. But today we will explore strategies on how to overcome these challenges, and we will demonstrate how European supercomputing resources can help businesses and thus drive innovation. But before we begin, I would like to review some guidelines for today's webinar. First of all, we would like to ask you to change your names so that we can see your full names. You can do this by going to participants, then either hover over your name or click on the three dots, and then click on rename. We think this will create a more personal atmosphere and ensure that we as a group feel more connected. Another important piece of information, today's session will be recorded, as I said previously, but participants' names and faces will not be visible on the recording. We would also like to ask you to keep your microphones muted during the presentations. Of course, you are very welcome to ask questions or share your thoughts in the chat at any time. And you will also have the opportunity at the end of each presentation to ask questions, and we will have a larger open-end Q&A session at the end of the webinar. So I'm very much looking forward to engaging discussions. So today's speakers are Isabell Claus, who's co-managing director of thinkers.ai. And Isabell will discuss the widespread applications of AI across industries and the strategic advantage of AI readiness. Next, we have Felix Stollenwerk, who's a senior research scientist at AI Sweden. And Felix will present GPT-SW3, the first large language model for Swedish and Nordic languages. And he will tell us more about its training, evaluation, and applications. Following Felix, we welcome Yashas Rattehalli, who's founder and CEO of hercules.ai. And Yashas will explore the future of work with AI employees and how to use large language models to perform complex cognitive tasks within enterprises. Our last speaker for today is Simeon Harrison, who's a trainer for high-performance computing, big data analytics, and AI at our very own EuroCC Austria and BSc Research Center, TOV. And Simeon will talk about large language model training and fine-tuning, and about how to use the power of European supercomputers and the knowledge of competence centers to drive innovation. And we'll also include a short demo. So thanks again for joining us today. And it is my pleasure to introduce our first speaker, Isabell.
Hello. Hi.
Hi, Isabell. Isabell is a co-managing director of thinkers.ai, and she has a proven track record in the tech industry. She has been recognized for her achievements, including winning the Europe State Award in 2022 and being named Innovator of the Year in Austria in 2023. And she also has expertise in the areas of cybersecurity. And I think we are going to hear more about all that in your presentation. Thank you, Isabell.
Thank you very much, Eva. I'm very glad to be here and to give you some insights that we see in the European and international market on LLM application. I'm going to share my screen. And you should be able to see it. Maybe you can give me quick feedback, Eva.
Yes, thank you. We see your slides.
Great. So the topic of today is the application of LLMs, and I think that's a very rapidly growing market actually internationally. It's already a race, let's put it like this, and we are focusing on a certain application which is making web search for companies and institutions more qualitative, or bringing more quality into web search, because we experienced that early information and correct and trustful information has a special value in the B2B field and is hardly covered when it comes to really broad topics. So we run an application and do a digitally autonomous technology in the background that screens the web, certain web pages, a big amount of web pages actually, in various sectors, from research coming to news, coming to company websites and so on. And for what do we do it? Well, we find there are lots of business opportunities. We also find important early warning information for risk management, for instance, for public institutions. We also find a lot of early information on technology development and other use cases like grant monitoring and others. So we go away from keyword search to more advanced search using LLMs to really skip the whole spam and advertisements effect in the web search and going to a more quality data set. Well, I was asked to present a little bit what we see developing with the rapid development of LLMs. And I think it's very clear that all business areas, any kind of department, and also any kind of sector is currently really intensely caring about AI. And AI today means generative AI or LLM application in its complete value chains. So to give some examples, our task is for construction industry to screen for new projects globally, internationally, or nationally, coming down to federal states. Also, we look for biotech companies which hypotheses are not yet focused on, what is important, what is maybe already researched, so not focusing on something that is already known and focusing on really valuable tasks. Another area, marketing intelligence, also important for very many sectors like financial industries, banking, insurances, and all that. We see a lot of developments, not only in big companies, but also medium-sized companies, a lot of interest. So the internal resistance is much going back, and projects are basically coming up in any sector and also on the value chain at any place. I would like to quote some Gartner statements, which says in latest research between 2024 and 2027, about 725 billion US dollars will be invested in AI, only in Western Europe. This is a very big market, and I think Europe consists more of users instead of providers, which is not a perfect situation, but I think and I hope that this market is going to grow also because somebody has to take up and to pick up something of this big cake of investments. What we see currently is that LLM use cases focus on 3 areas. One is knowledge management, second is summarization, and the third one is content generation. Also, Gartner confirms that these are very important use cases as of now. However, we grow from, let's say, pushing internal processes and efficiency to even getting a part of products, of knowledge products from companies. So this is moving very rapidly and faster than ever expected. So it's not a bubble actually, but it's a very big trend that basically all segments and sectors are following. So I think it's very worth to look at LLM use cases and high performance computing in this regard. The vision at the end is for many to think big also. Maybe this is a European idea, but more driven by other countries and regions. The basic idea is that faster computing leads to faster innovation, and at the end, faster innovation leads to faster solutions, even to hard problems, so coming to diseases or energy problems and climate crisis. And at the end, the big wish or the big goal is also longer and better life, enabled by technology. So think big approach and faster innovation is unfortunately not really driven by European companies yet, but I think companies need to catch up, and also industries and also security, politicians and so on. I think there is a lot of things happening, and I'm sure HPC centers are growing a lot because this is something that is expectable to grow even further in the future. We don't have the best position in Europe, to have leadership in this field. But I think we're well positioned in the B2B place from a physical industry perspective and coming to a technology ecosystem. So I hope very much that we see many more other applications in the B2B sector especially. Overall, the race is on. AI is a global race, actually. It's a race against time. It's a race against new and old players in any market, any segment. And last but not least, it will not be the last tech disruption that we saw, but we expect other disruption coming afterwards. And also interesting will be the absorption by market players and industries. What is the usual way, like how companies are acting? Well, at the beginning, there were hardly AI applications. This changed a lot within a very short time. So many more companies are caring about applying LLMs in their internal processes, but also in their products. They usually grow with a planning, with a strategy, with a partner selection, because many times LLM application means quite some investment. So you are faster when selecting a partner that can help you at least for the first steps. The third stage that companies usually take is to make pilot projects, to see a little proof, to get trust in technology, and to closer cooperate also with partners. Especially in this phase already, it's important that there are European players and there is European technology, because many companies and in the B2B sector need this trust for keeping their data somewhere in Europe, at least if it's not in a company. This usually grows very fast from pilot projects because they're very successful actually. So LLMs also develop very fast in their quality, which means that they convince users very quickly for their use cases. And so they grow from a pilot project quite quickly into an application in first defined fields, and later on the plan is to have AI in all fields or all departments. The job profiles, I think we're going to concentrate on that a little later. Yes, I think they will change a lot. We expect, we expect that all companies and departments will have some kind of data steward per department actually. So data will actually be part of everyday's work and will take over a lot of processes. The main thing which opens up LLM usage in companies is use cases, use cases, use cases. This means learning from success stories. So also what we as thinkers.ai find on the web is a lot of success stories on AI in various sectors. And this is the knowledge base for companies on where to put investments. So it's a decision support even in this field. So it's not that companies experience and try out various things. No, this changed from last year to this year into we want to have success stories. We want to learn from success stories, and we don't want experiments only. The main decision for applying LLM is not a technical, actually, it's a business value decision. So it's very clear in which value chain process can I use AI, where can I be faster or better in my products than our competitors. So this is the main decision. So we are also working a lot, not in IT departments, but in any other department, because they have the value of LLMs and they need to be convinced. And at the end of the day, what comes out and what is known now also, it's a little bit of a learning curve, not only on the technical side, but more on the management side, on the change management side, because working with LLMs, with prompting and various forms actually needs some training. So this was my little overview on applications. I'm very happy to talk about special sectors as well. There are lots, as I said in the beginning, and so are applications. So it's difficult to decide what is interesting to use. I'm happy for any questions, focusing on details of this broad spectrum and portfolio of LLM use cases. Thank you.
Let's continue with our second speaker, Felix Stollenwerk, who is a senior research scientist at AI Sweden, as I previously mentioned. Felix has a PhD in theoretical physics and brings a perspective to his work, which primarily focuses on large language models and natural language understanding. And Felix has already spent quite some years in the machine learning industries. And over the past 2 years at AI Sweden, he has been heavily involved in projects related to GPT. And he's also involved in various European Union initiatives. So Felix, welcome. We are going to continue with Yashas Rattehalli, who will talk more about the topic of digital assistants and digital employees. Yashas is the founder and CEO of hercules.ai, which is a deep tech startup. And their main business are AI-driven virtual employees for businesses. Yashas has extensive experience in machine learning and artificial intelligence, and he was previously involved in the development of automated machine learning at DataRobot, and he held leadership positions at tech giants like Amazon and Accenture. Yashas began his journey in highly technical roles, but then transitioned into strategic business leadership. And currently based in Germany, he leads hercules.ai and the company's endeavor to transform work life. So Yashas will now tell us more about how AI workers are reshaping the landscape of work. Thank you, Yashas.
Thank you, Iva. I mean, can you all see my screen?
Not yet. Now we can see your screen, although your slides are not full screen yet.
1 minute. Yeah, I mean, I'll just be using a couple of slides, so I'll be using like the demo here. So thank you, first of all, I mean, Iva, for the nice introduction, and welcome everyone. I mean, thank you for taking time to be part of this presentation. Very good afternoon. I mean, if you're tuning in from Europe, good morning and good evening if you're tuning in from other parts of the world. So let me start by taking you all 200 years back, right? So the 18th century England. So that's when the Industrial Revolution started. But before that, a lot of physical labor used to be done manually, right? I mean, if you are talking about making furnitures, they were like handmade, textiles were like handmade. And then suddenly like the machines came in, and a lot of these physical labor got transitioned from manual labor to automated sort of like labor. And that created a lot of scare. Back then, there was a lot of like protests, factories were burned down. People thought that their jobs would be like taken. Now, if we look back after 200 years, it sounds something like funny because at the end of the day, I mean, all the great goods and services which we are enjoying today and the quality of life which we are having today can be directly plotted back to that industrial revolution, right? I mean, if people back then decided, no, I mean, we will not develop machines and we will stop at there, we will still be like making all these furnitures by hand, and we will be doing like a lot of like physical labor. And back then we didn't envision that a lot of this jobs will be taken away by machines, but in future we will have new jobs, right? Computer jobs, the desk jobs, the jobs which we are doing today, right? So this is how, I mean, like the evolution of job usually happens, where there's like some disruptive technology which comes in, and then the landscape of like job changes. So now, I mean, we have AI models which can like reason and like solve problems, and the world was made aware of it by the very popular ChatGPT. The next logical evolution for that is, because ChatGPT can only like give you advices or like answers, right? It does not go ahead and do your task. But what if ChatGPT has hands and legs, right? I mean, what if it can use tools and databases and like applications, what you use in real life, and it can go ahead and complete those tasks for you, right? So that's going to be the next revolution in AI, and that's called as like AI agents in our technical world. And AI agents are going to like automate the cognitive part of the labor, right? Similar to like what we were discussing regarding the physical labor which happened during the Industrial Revolution. The same thing will happen with the cognitive labor, and that's for the good. Again, I mean, like there might be like some scare, and also like there are like a lot of internet memes going around that like a lot of jobs will be taken away, and there are like some memes which are apt as well, which says that, hey, I mean, AI will not take your job. Humans using AI will take your job, and that is indeed true. And so we should all be building towards that vision. And we in Hercules AI believe in that thesis, and that's what like we are building for. So our mission is to like make every European enterprise more productive by building virtual employees or AI employees or digital workers, right? So what we do, we take these wonderful AI models, which can like reason and like solve problems, and we connect it to different applications, tools, and databases, so that these AI models can complete your task. So I'll be talking a bit more in detail about that. But before that, just wanted to like highlight, there are like two different sort of like parameters, right? I mean, at least in my mind, how I see the evolution will happen. So the first is the intelligent layer. That's where like these AI models can reason and solve problems. And this is a area in which a lot of investment is going on. For example, OpenAI, Google, Microsoft, a lot of these companies have invested millions and billions of dollars to build this wonderful intelligence layer. But intelligence layer itself won't suffice. So we need to have a orchestration layer as well, right? I mean, like the connector layer, where this intelligence talks to your existing tools, applications, and databases in a seamless, user-friendly way, so that it can complete the task, right? So the revolution will happen in these two areas, the intelligence layer and the connector layer. And we in Hercules are working on both of these aspects. So I will go from a 40,000 foot overview maybe to a 20,000 foot overview, and like explain how we are tackling this problem. So we are an end-to-end SaaS platform, and we enable enterprises all across the world, and specifically like European enterprises, to build, manage, monitor, and deploy what we call AI employees or virtual employees. So without further ado, I will just give a short presentation, or rather a live demo, so that you can all connect the dots, right? I hope you all can still see my screen.
Yes.
Perfect. So let me take an example of Cisco, right? Cisco is a large organization with 10,000s of employees and hundreds of different applications, tools, and databases in their environment. And obviously, they have like a lot of processes, and they have like a lot of sort of like use cases which they would be building inside their organization. So let's see how virtual employees or digital workers can help a large company like Cisco. So once you log into the Hercules platform, you have two major sort of like components. So the first one is the marketplace, where we have pre-trained AI employees or digital workers. So what do I mean by AI employees in the first place, right? So AI employees are very similar to human employees. So how we evaluate human employees? For example, if I'm working in a marketing department, I would have the domain knowledge of marketing industry, and I would know how to use certain marketing tools, right? Like Adobe Omniture, Marketo, Google Analytics, so on and so forth. But if I am a human employee working in a customer support domain, I would have the knowledge of customer support domain, and I would know how to use Salesforce, ServiceNow, Gmail, Slack, and like a lot of tools which are used in that particular domain. So this is how we differentiate ourselves as people working in different industries, right? By domain knowledge and the tools we access to get the job done. So we are going with the same first principles, and we are building our AI employees with the same sort of like philosophy. Our AI employees are pre-trained with specific like domain-based intelligence, and also they know how to like access certain domain-specific tools, right? So for example, if you consider our customer support employee, which has been highlighted now, so this customer support employee, we are not saying that it will go ahead and like do all the work what your human employee does. It's just a boxed solution. So we have customer support, marketing, and like a couple of other employees, but all are boxed and comes with predefined scope, right? For example, our marketing analyst employee scope is defined as, hey, I mean, like this employee can create custom proposals based on your internal knowledge repository, and then it can reach out to your potential clients, right? So for example, historically, we would go to LinkedIn or like any other sort of like networking site and find potential customers, read about their company, and then come back to our internal document repository and then fine tune some message and then reach out to those particular customers, right? So that's how, I mean, like your marketing or like sales department works. So we are boxing that. We are going one after another. So we are saying that our marketing analyst comes with A, B, C, X, Y, Z sort of like capabilities, and that is completely like autonomous, right? So this is how, I mean, like these are like boxed and like very specific, and all your sort of mundane, boring works, you can give it to these AI employees. And the human employees can like start doing something more better, creative, and like much more sort of like valuable from an organization perspective, right? So that's the overall vision. But we understand that all companies use cases, we cannot build it using a marketplace. So we have a custom sort of like solution as well, where we have a no-code tool where you can build your own custom AI employee. And as I mentioned earlier, right, all you need to build an AI employee is the intelligence layer. So that will come from the large language models. And we prescribe our customers to build their own large language model, rather, I mean, like fine tune their own large language model within the platform itself, because within the platform, we have a flow where you can take open source large language models like Llama 2, Mistral, and other open source models. And then you can take your enterprise data and fine tune your large language model so that you have your business specific intelligence, right? For example, if I'm Cisco or TeamViewer or like SAP, I mean, like we have our own sort of like nuances and like business ontologies and taxonomies. And it's very important to like preserve that. So that's why we don't prescribe our customers to use something like ChatGPT or Google or like Anthropy. We ask them to like fine tune it and like use their own sort of like large language models within the platform, right? So for example, let's quickly like build a AI employee, right? So this is a vanilla AI employee. It needs intelligence. So right now, I mean, just for the sake of this demonstration, I'll not use the fine-tuned LLM. I'll just use OpenAI. So you can just connect the OpenAI based LLM. And then if you're building for example, customer support domain, you need to connect the applications, right? So your applications can be Salesforce, ServiceNow, Slack, Gmail, whatever is required for your customer support use case. Just you have to drag and drop, and then you have to just connect it. And then the model will get trained for like a few hours, and then you will have your custom AI employee ready. And once you have your custom AI employee ready, you can deploy them. This is again like done automatically. I mean, in the backend, we Dockerize everything and like it's orchestrated by Kubernetes. So you will have your AI employees working for you, and then you can go ahead and give them tasks, right? For example, let's say I want to go and fetch some of the documents from internal repository. Because I'm trying to like upsell a new product called a Switch, which is a Cisco product, and I'm working in the sales department. So I want to understand what are the right customer accounts to target. And also I want to understand if there is like some other account executive or like salesperson who has already like gone ahead and like upsold that particular product, so that I can learn the best practices from that person, right? And then I want to like persist all my knowledge in a document and then send it to my wider team so that they need not do this work, right? Though they can rely on my experience. If I have to do this manually, I have to get the customer information from CRMs like Salesforce. Then I have to like get account executive information from internal databases. Then the best practices information is in like 200-page PDF document, which I can show. And the particular client information is hidden in the 32nd page. So I have to go through all of that. I have to sit, write everything down, and then convert it into a PDF, attach into an email, write a nice email, and then send it to my whole team, right? It will easily take 2 or 3 hours, depending on like how productive you are. But with using AI employees, you can quickly like do it in like 9 or 10 minutes because it does all the job for you. And it also obviously like gives you like step-by-step analysis, right? Why exactly it took certain decisions. For example, the first thing which it says is to answer this question, I need to find out, I mean, like where the data is, right? Is the data is in Salesforce, ServiceNow, PDF documents. So it makes that decision first. So once it plans out the steps, then it goes ahead and like makes those API calls and gets that data and sequentially like makes an informed decision to finally like come up with the final document which you need, right? And eventually like I would get an email in my email with all the things written down in a PDF document with a nice sort of like layout and everything. So this is how, I mean, like we are trying to like automate a lot of like processes and works by creating digital workers or AI employees. And as I mentioned, I mean, like it's not mimicking exact human capabilities. It is like very boxed in terms of like their capabilities. So we want to like build autonomous AI employees where there's no human intervention or less human intervention as possible. But obviously you can give feedback to these AI employees. You can say, hey, I mean, like what you did is not right. I mean, this is how it works in our organization. Because initially, like when you launch a new AI employee, treat it as like a new employee joining your company, right? It needs some time for like onboarding. And we use something called as like reinforcement learning with human feedback and direct reference optimization to keep on improving our models so that over time these models learn and become much better. But the initial period, it's always good to like give feedbacks and like chat with the model and like make sure that the model persists some of the nuances which is represented in your business, but the model does not understand, right? So you should help the model understand those. So it's always good to like give more feedback. So in essence, I mean, like, so this is what we are doing. And more importantly, this is all in the orchestration layer, right? I mean, if you remember my initial comments, I mentioned that the evolution of like AI is happening in 2 directions. One is the intelligence layer, and the other one is the orchestration or the connection layer, where you connect the AI models to like various tools and database and get stuff done. So most of the demo which I gave now was concentrated on the Hercules AI platform, which sits in this connection layer, where we are connecting it to like different tools and like getting the task automated. But there is the intelligence layer as well, right? Wherein you ask these models. I mean, if you remember from my presentation, I went through this demo by using some of the AI models. And also I mentioned that these AI models, we are asking clients to use open source LLMs or like open source AI models and then fine tuning it with their enterprise data, right? So, but in essence, this still is some generic AI model. Though you fine tune it on enterprise data, the quality of like these models will not improve significantly. So we as a startup also wanted to like build some foundational models which are built grounds up for enterprise use cases, right? For example, if you look at GPT-4 or like any other OpenAI based models or any other models which are in public domain, these are all built for B2C use cases. These are all built from the perspective of like general world applications, right? These are not built for like enterprise applications. So we were always thinking, I mean, hey, I mean, like we have the technical know-how, but we don't have deep pockets or GPUs to build these large enterprise models where these models understands how to use all these applications and tools and databases, right? For example, how we humans learn, we go to YouTube, we watch Salesforce video and check how the Salesforce is used, or we go to Coursera, Udemy, a lot of these sites and figure out how to like use certain applications, right? So this was missing. And we were using all these open source models, but those were not good. And that's where EuroCC and ENCCS came into our like sort of like help. So we are collaborating with ENCCS and also like EuroCC to build these large enterprise models, which can, in a multimodal manner, understand the enterprise structure, right? I mean, like how to use certain applications, how to like, for example, we are also like building our agents to make sure that they can open the browser and like do some sort of like browser-based application actions as well. And for all of that stuff, we need a multimodal sort of like enterprise model. And for those deep tech sort of like collaborations, we are like relying on ENCCS and EuroCC for their GPUs, and really like thankful for that. So yeah, I mean, we are still in a very, very early phase of our evolution as a startup, and also like with our collaboration on these like larger vision items. So yeah, I mean, looking forward for this exciting sort of like few years ahead of us. And yeah, I mean, thank you for all of your time. I mean, happy to answer any of your questions, and feel free to like reach out to me. This is my email ID, or you can also like directly like visit our site and then try to get a demo. It will take you guys to my Calendly, and then you can directly schedule a meeting. Yeah, or you can also join the wait list, and I'll be happy to like work with your corporate sort of like ecosystem as well. Any questions?
Thank you so much, Yashas. Yes, any questions from the audience? Then I have a question, and then let's see if some more arrive by the end. How long does it usually take to onboard such an AI employee?
Sorry, to onboard?
Yes.
Yep. So it depends on the use case. The more the feedback you give, the more data it is built on initially, right? Because see, once we have a open source LLM and like then we fine tune it with enterprise data. Let's say there's a significant chunk of enterprise data, so then the model becomes more and like more reliable because we would have fine tuned it on these enterprise data, so it understands your ontologies and taxonomies better. And on top of that, I mean, like once you start using the models, you start giving the feedback, it can get onboarded pretty quickly. But if you don't have any data in the first place, and if you're just relying on the feedback, it may take a while. So it's a very contextual thing. It depends on the organization, depends on the amount of like data which is available and all that stuff.
Okay, perfect. Yeah, there is a question in the chat. How much data is required to fine tune, like minimum company size, or is there an on-premise solution?
Yeah. So I mean, yeah, I mean, we are I mean, like very much sort of like keen on making this offering on-premise, on private cloud, public cloud. I mean, right now, I mean, we are a startup, so we have not split in all directions. I mean, it depends on the client, but yes, I mean, we do support on-premise sort of like installations as well, where everything will be like secure in your environment. That's why we prescribe customers as well to use this open source sort of like models and like fine tune it on your data. And again, to like fine tune it, I mean, how much data is required? Again, it depends on the use case. But for fine tuning, the more the data is better, and also like the cleaner the data is better. It's not only about like how much data you have, but how good quality data you have, right? I mean, it's not just fine tuning it on like random data. So it depends on both the quality of the data set and also like the quantity of the data set. Both matters.
Thank you, Yashas. I'd say let's continue the discussion in the Q&A session. And now let's hand over to our next presenter, Simeon Harrison, our very own Simeon Harrison, who's a seasoned HPC, high performance data analytics and AI trainer. And Simeon has a background in mechanical engineering, but his true passion lies in the dynamic and rapidly evolving areas of deep learning and AI. And Simeon has over a decade of experience in teaching, and I'm very much looking forward to him sharing his knowledge with us. Thank you, Simeon.
Thanks, Eva. Thanks for this introduction. That was so good that I might take that for my LinkedIn profile. Should have taken notes. Well, hello everyone. Welcome to this webinar. What I'm going to talk about is the connection between large language models and supercomputers. And to be more specific, we're talking about European supercomputers here, and we'd like to explore if that's actually a match made in heaven. What are the pros and cons of these large number crunching beasts? Well, but before we actually dive into the topic, we basically already know what large language models are here for, right? So I just gave you a very brief overview here. All these applications have been made possible because of the transformer architecture that is under the hood of all these large language models. And why I've got this slide here, even though you might know that yourself already, is you really need to know your use case. That's very important if you approach a project that you'd like to tackle with a large language model. Really know your use case, because the model that you'll choose later on will depend on that use case. Well, we've been hearing a lot about RAG and fine-tuning already so far, and I'm sure you've already heard about the hyped new discipline of prompt engineering. And just to get you an idea, an overview of how you could place these buzzwords. Well, prompt engineering is something that you could basically do from your laptop. So simply by providing a large language model with useful prompts, you get the desired output, right? So that's pretty easy. You don't need to host the large language model on your laptop. You don't need to fine train it. But as you go along, further along the line, it becomes more compute intense. So RAG is something, depending on the use case, that you might also do on your own machine or on hosted services. But as soon as it gets to fine-tuning a model, then you really need significant compute power. And this is where HPC comes into play, HPC standing for high performance computing. And if you go all the way and want to train a model from scratch, then you don't just need any old HPC supercomputer, but you'd have to use one of the really big clusters that are available in Europe as well. So let's have a look at the difference between fine-tuning and RAG, since this is probably the area that is most applicable to a business use case. It's often hard to decide whether you should go for that new trendy thing called RAG that has been around, I think, since 2020, which stands for Retrieval Augmented Generation. And the secret behind it is you provide an already pre-trained large language model with your company's database, with all the data that you want to feed it with. And that makes a very good query system. So there are two parts to it. So the language model retrieves the information from that data, and then it augments the answer. So for example, if you had a company chatbot and you want to type in, dear chatbot, do I still have holidays available? Can I still go on a holiday? I'd like to have half a day tomorrow. Well, then that system should be able to tell you, well, yes, you do still have, I don't know, 10 days of holidays left on your account. And actually, no, you can't take half a day of holiday. You'd have to take the whole day, for example. So this is information that it retrieves from your company's documentation, from other situations that have already been handled and so on. And then it generates the answer accordingly. Well, the fantastic thing about that is that you minimize hallucinations, right? So that's a huge problem with large language models. We know about that. and you'd want a precise answer in such a situation. So that would be a perfect application for retrieval augmented generation. And very often also your whole repository of your data that you have in a company is changing really quickly, and you'd like to keep that up to date. Well, it would be really cumbersome each time you had some change, significant change in your data to fine tune the model. So in that case, again, RAG would be your solution. And then again, it's also, because it's that two-step approach, it makes it easier to get an answer if you want to know where that model has the information from, which is much more difficult if something is already baked into the system. So why do we bother about fine-tuning at all? Well, fine-tuning has a very different use case where that comes into play, especially if you're interested in a certain vocabulary that might be some sort of lingo that you use within your company, or maybe within that domain, and that's general use these base models just don't come up with. So in such a situation, you might want to fine-tune the whole model with the information you provided with. It could also be documents from your company, whatever, and that is then baked into the system. So the system parameters are actually changed then. And then you can do queries just as before. However, be aware that system will tend, even if not as much as a just pre-trained system, it will still tend to hallucinate. So something that you might want to consider is actually both. In many use cases for companies, they do a fine-tuning and then also go the RAG approach. So they have the best of both worlds. But just to make it clear what the difference here actually is. There are tons of transformer models out there, and one of the best known sites to find these is the Hugging Face website. So there basically you get all the relevant info about the models, and you also get a short introduction to each model. But tell you what, I'll just head over to the website and show you there. So you should be able to see the website now, hopefully. If you go to the Hugging Face website, and definitely it's not just Hugging Face that offers you models. You could go to NVIDIA, to as far as I know, Intel and IBM as well. They also have their own repositories. So there are many out there, but Hugging Face is one of the best known and has been there since the beginning, basically. So here, if you go on models, you can already easily make some sort of filtering that you want your model for. There's a huge there's abundant use cases here that might be applicable to. So in our case, I want to do something with natural language processing, and I want to create a chatbot that's no longer here as conversational AI as it used to be. It's now called text generation, right? Because it's basically all the same. It generates text. And now I know all about the trending models, but tell you what, I want the most likes, which are the most popular models. And here you can already see some of the big names are here, like the Llama, created by Meta, formerly known as Facebook. Or very trendy at the moment is the one from Mistral, as far as I know, a French startup company that have come up with a really powerful model that competes with ChatGPT or GPT-4, as a matter of fact. And you can already get a glimpse of the size of the model. So 70 billion parameters might be too much for me, so I might go for the Mistral with 7 billion parameters here. So I'll click on that, and there you get all the information that you need, basically. So If you scroll down here, you get ideas of how to use the model. You might even, depends on the model that you choose, you might also get short tutorials there. You're informed about the license that needs to be applied and so on. And most of all, you get the name of the model that you will then import into your code. So I might want to copy that here, just in case I need it later. Okay. Let me head back to my PowerPoint presentation. If I find my way back, there it is. The most important thing that you need to do before you actually approach such a project is you need to prepare your data. We're not really talking about that here today. Time is too short, but still it has to be emphasized. It is an absolutely underestimated part of model building. It takes an enormous amount of effort to get your data ready. I mean, obviously the beauty of some of these models is that you don't need structured data, but it depends what you want to do with it. And in fine-tuning use cases, it would be ideal not just to have structured data, but also labeled data, which would give you the best results in such a situation. And always remember that if you spend time here, that's not time wasted, because that will show in the final result, in the quality of the model that you're going to use. Now, if we approach a supercomputer, a high-performance computer, they usually have the same setup. So what makes it a bit different to what you might be used to somewhere else is the following. Well, you as a user, you log on to the supercomputer via a login node. Now, I'll show you a bit later on the Vienna Scientific Cluster. We can log in 2 ways. Basically, we can log in via SSH and the command line. Then you end up on a login node, or we could actually use the Jupyter Hub, which I'll show you. And we won't end up on the login node, but we'll already end up on one of the compute nodes where computation actually happens. But nonetheless, what makes it different is we have to interact with the whole machine through the batch system, because this is a shared environment, and the batch system, in our case, it's called Slurm, makes sure that these jobs that you send off are scheduled in the most efficient way. We don't want to waste compute resources, so we need this batch system in place. And it also makes sure that this is somehow evenly distributed. And you have storage that you can access, and you can access the compute nodes, then send off a job to the compute nodes via the batch system. I'll show you how that's done. And the whole thing is embedded in a very fast network, the interconnect in that case. So this is a setup that you will typically find, not just in Austria from where we are from, but also on the other European machines. We'll be dealing, however, with the Vienna Scientific Cluster. And these are the 2 flagship computers that we have in the VSC. It's VSC4 and VSC5. And very soon we'll get a new system. It should arrive this summer, and hopefully it'll be operational in half a year. We'll see about that. And the interesting bit that we like to see, obviously, is that baby here that you have on the screen. And this is an A100 GPU from NVIDIA, and we have 60 of these on VSC5. So we'll be logging into VSC5. And in addition, we also have 40 NVIDIA A40 nodes, each with 2 GPUs per node and 40 gig per GPU. On one of these nodes, you also have, let me call them regular compute cores, even though they're very powerful, they're special cores. There are 128 on a node of the NVIDIA A100, which could be very useful if you need to do some offloading, for example, on the CPU in the meantime, if your memory becomes too small. The future machine, which will be called Musica, will boast even more, but as I said, that's not here yet. We'll have to wait for that just that little bit more. But as soon as you deal with these things, the first problems arise. And one of these problems is that you'll notice that your data doesn't fit in memory. Well, that's easily solved. I'll show you in the next slide how that's done. But the more tricky bit is if the model is too large. So if that llama, for example, from Meta sits there with its 70 billion parameters, it might discover that it's just too large for the GPU that we have. So how can you roughly tell how much memory you need? Well, if we take the Mistral 7B model that I just showed you on Hugging Face, well, that has roughly speaking 7 billion parameters. Well, every parameter takes up 4 bytes. So we're already at 28 gigs of GPU memory that we need here. If you take in the CPU memory, well, we have two GPUs on one node. So this is the amount you might need on a certain setup. Not here on the BSC, since we'll just be loading the model once and then distribute it onto the GPUs. But that could, depending on the hardware you're using, could also be relevant. So you can imagine as soon as you take a model like let's take the Llama, for example, with its 70 billion parameters, well, then you have a factor 10 here that would be larger. And then we run into troubles, as you can see. So there are solutions to that. Well, the first thing, if your data doesn't fit in memory, that's not too bad. We've got data parallelism for that. It's been in use for a while. Essentially, what this means is that every GPU gets the full copy of the model. Every GPU has the full Llama in this case, or Mistral, or whichever model you're using, and only the data is split up, and afterwards the gradients are averaged out, are collected and that averaged out. So that's the easier situation. The more tricky situation is if you need to split up the Llama. So if you have 4 GPUs available, you need to split up your Llama in 4 pieces, essentially, and place one piece on each GPU. Obviously, you need to have enough GPUs to accommodate that. So you need to make sure that a fourth of the model size still fits in one GPU. So, for example, on the BSC, to train the let's take the Mistral 8 times 7 billion parameters, I would need at least 6 nodes, so 12 GPUs to train that. Otherwise, I couldn't get the single shards into the memory. So this is something that you need to think about. There are basically 2 ways of splitting up your model, roughly speaking, and there are ways, and we'll be using that merge these together in a very clever way. But basically, there's pipeline parallel, which splits the model along the layers. That means that the biggest layer still needs to be able to fit into the memory of a GPU. If that is not possible, then you're in trouble. Okay, then you need something else. So each GPU gets one or several layers, and the results are synchronized after every step. So tensor parallel is another way to split the model, where you split through each layer. You split up the tensors, respectively, into several chunks, and each GPU gets one of these chunks. And then again, the shards get processed separately. And in the end, we need to synchronize the results. So with fine-tuning a model on the VSC, basically what you need is the VSC access, and we'll talk about that as well. You need a working environment for whichever language you're using, model you're using. You need your training data, you need your Python scripts, presumably, or your scripts in whichever language. You might need config files and a Slurm script, and then it's off you go. So let's have a look at that and how that is done on the VSC. So basically, I've already logged on to the VSC. I can show you afterwards if you're interested. That's pretty easy. You just need your username and password, and also your mobile phone, since there is a two-factor authentication behind that. And then you're good to go. So basically what I need is, I might need a config file like I have here, since we use the fully sharded data parallel here, which basically brings in all the parallelization steps. That might actually not be necessary for the model we are using, but this is, so to speak, a one-size-fits-all approach, if you will. Then we need our training script. In that case, that's a Python script that also goes through different prompts that I can pass later on in my script that I need for the scheduler for Slurm. And yeah, that's basically it. There might be some additional scripts to make it easier accessible, but basically that's it. So what is special in that case is the Slurm script. Let me scroll up to the top. So a Slurm script asks for some resources on a system. So in this case here, we want 2 nodes, and these 2 nodes have 2 GPUs each, and will run only one task per node, because basically we'll be using accelerate, that's from Hugging Face, in connection with this FSTP that I just showed in a config file, to make sure our model and data is split up nicely and all the GPUs are used evenly. And basically I just need to start one task and it'll take care of the rest. That's why we have that here. Then I need to load an environment that I've previously built. That's got all the packages in there that I need. I might want to know the names of my nodes and so on. Got a bit of debug code here. And then finally, I'll define this launcher here that takes in the config file and also my Python program, the trainer, and I'll also pass it some more of these arguments here. So I don't have to change that within the Python file, which is useful. I'll just do that here. And that's basically it. In the end, I want to combine these two. That's what we got in the end to launch that. Okay, so what I need is a terminal. I'll take a terminal. I'll have a look at the queue, because basically if I send off a job, it ends up in the queue. So I go sq -u $user. And here I can see there's a job running. Actually, there are 2 jobs running. One is my Jupyter notebook, which is on a compute node. And the other one here is also a large language model that is training. It has already been training. It has already been running for a while. I can see that here for 18 minutes. And it's on these 2 nodes. Actually, I'll have a look at these nodes quickly and see if these GPUs are in full use. So what I'll do is I'll copy the name of the node here. I'll open up another terminal. And I'll SSH onto that node. That means I'll actually, can imagine it as I'll go and sit on that node, and then I can see what's going on there. All right, it wants my password. I hope I'll type that in correctly. There we go. Now we can have a look at what's going on the GPUs. So you can see these GPUs are pretty busy. Both of them are at 100%, so they're pretty much maxed out. If I have a look at the memory, ooh, that's right at the edge there, as you can see. That's just with one node. Obviously, I could do the same with the other node and have a look at that too. When estimating how much memory you need, you should always also take into account that there's an overhead, because there's other stuff there as well, not just your model going on. So you never have the full memory available that is there in theory. But this is a good sign. We want the GPUs to be maxed out when doing a training like that. But actually, I'm going to cancel that job now because I want to send off the script that we just had a look at. So I'll go cancel. Won't be finishing it. Usually I'll work from the command line. It's a bit different copying stuff here. Now let's have a look. What's going on here? It's being cancelled. Okay, so that'll terminate now, and that's it. So we can send off our script. So I'll go sbatch. Whoops, sbatch. Now I just need the name of my script, and it was called LLM Slurm Mistral. Yeah, autocomplete helps here. And off it goes. And now I submitted this this job. I get a job ID there. If I have a look at the queue again, you can now see that this new job here, that's the same job ID, that this is now running. The time still says invalid because it's just starting up, and it'll start counting very soon, but it's already running. Okay, so this is how you send off a job. Now, it would take probably an hour and 8 minutes to train with these resources. And also, what I didn't show you before is we're using just a random data set that we got from Hugging Face just to fine tune that. Basically, you could use your own there. So what I'll do here, I'll go cancel, and I'll cancel that again. This one too. Okay, and now I've already trained it before. We'd like to test the inference. Now you'll see these HPC systems are fantastic to fine tune your model. Would be the same if you'd have trouble with a RAG. You could tokenize your data on a supercomputer. That's absolutely possible. But they're not very good for inference because we have this scheduled system here and you don't get the immediate response. So what I'll show you here in the inference, there's my Python code. I want to test my model and I just want to know what is a large language model. So that's what we want to know. If I have a look at the inference script, have I got it here somewhere? No, I need to open it. I think that's the one. Let's have a look at that. Yeah, we've got this script. Okay, so I'll send this off now. So I need to sbatch that too. Of course, that could be done smoother then, but I want to show you that it's actually not the ideal environment to do that. Now I've submitted the job. Let's see if it's running. Yep, it is running. There it is. What I'll do now is I'll go into the outputs and have a look at where it might be. So that should be it. Let's see if it's already there. No, it's still working. So you see the inference isn't prompt. Well, admittedly, we could have improved quite a bit with the script of the inference. However, hosting the model, and that's the message here, hosting the model should not be done on an HPC system. You should host it somewhere else on a platform like Hugging Face or on your company's server or wherever the cloud provider, whatever. But for fine-tuning, this is the ideal tool. So let's see if it's ready now. Oh, yeah, looks as if it's complete. Let's see if we've got a useful answer. Have you heard of large language models? And by the way, we're telling the system, and this has been baked in during the fine-tuning, we are telling the system to be helpful, respectful, honest, and so on, to reduce the possibility of hallucinations. If you try and prompt it to do something, let's say rude or something out of order, it will tell you, sorry, I've not been trained to do that. Okay, so this has been hard trained into the parameters. Okay, so it tells us, yes, this is a large language model, uses a natural network to process, blah, blah, blah. Yeah, it even got a bit of a grammatical error here. That might be because simply the data set that we provided with is not very good. So the principle stands for garbage in, garbage out. If I do that again, I'd get a different answer, which might be more useful. But just to demonstrate that to you. Right, so I'll be heading back to my slides, and I'll just tell you how you could try that out yourself. Well, what is EuroCC and what am I telling you all of this? Well, you've already heard EuroCC is an EU-funded project. It is fully funded, and it has set up 32 competence centers all across Austria. And EuroCC Austria is one of them, and we're the service provider for AI, HPC, and HPDA. So our services include basically consulting, training, and infrastructure. So if you're a business and you want to train or fine-tune, let's put it that way, your own large language model, or use the RAG approach, you could come to us and say, look, this is my data. You're responsible for your data, so you need to be in charge of your data. This is my data. I'd like to fine-tune a large language model. So if you're not able to deal with these HPC systems, feel free also to use our consulting. If you need even more compute power, there's more out there. There's Lumi, there's Leonardo. These are the two most powerful supercomputers in Europe, and number 5 and 6, I think, in the world. To get access to these, they belong to the EuroHPC joint undertaking system. We can help you with the application. Here's the link. You'll get the slides afterwards. The link for the calls for proposals. If you want to train a whole model, let's say, these are the So to wrap up, you need to know whether you want to go the RAG or fine-tuning approach or both. You need that training from scratch is just for developers. We know that now. And if you need access to a supercomputer or consulting or training in that area, do contact us, please. So you're welcome to stay in touch. There's also a link, one of my colleagues might post that in the chat, to F6S, if you've heard of that before. That is still possible, even if the information is not up to date there. So if you want to use that to get in touch with us, feel free to do so. Otherwise, you have our contact details here. And with that, I'm finally done with my talk. Thank you so much.